Good morning, everybody. It's okay. Welcome to the panel discussion. The discussion of leveraging robotic and automation now, next, and beyond. Hi, my name is Alex Ling. I'm an interim CEO for Intuitive. Intuitive is the innovation and enterprise company for NTU. We are focusing very much on commercialization. So we are focusing on basically bringing technology to the market. Today's topics is something that I think we can see that very, very relevant to all of us, especially in the space of coming post-COVID, because everything seems to be digitalized. So we are literally seeing the advancement of robotic and automation and basically progressing faster, safer, cheaper, and more efficient. So you are seeing robotic in all walks of life. In fact, this morning I just saw an article that robotic has now begun to even change into real estate. Which is very, very resistant to include digital transformation. So this is a very encouraging sign. So with a lot of 5G coming up the horizon, and we have AI and aging population, I think robotic will start playing a very important role in our life. So not just in the factory, but in every day of our life, which later we will be able to see some of the example. So there are always positive and negative connotation around any technology. You like it, you hate it, and some of us may even worry about that robots going to take over, AI is going to take over. So today we will have a discussion about how all these things are going to change us, and I will have my panel of speakers down here. And the panel of speakers, let me just give a very quick overview of them. Dr. Massaro is from the Advanced Robotics Center in NUS. He will share quite a fair bit of what is coming online. Prof. Chen, the CEO of Transformer Robotics, will show you a lot of industry robot his company is doing. And by the way, Prof. Chen is also a professor in NTU. Gabriel is from Merlaps. Share with some very interesting thing that they're developing, as well as Yongxin. Yongxin is from momentous, how he will share about the technology that they develop using AI and making controlling robots become a lot more easy. So without further ado, let me call upon my first speaker, Dr. Massaro. Dr. Massaro, please.
Thank you, Alex. Let's look at how we can bring robotics out of the factory to our everyday lives. I call this everyday robotics, where we want to move from the left, structured environment, where there is human-robot separation, to our grocery aisles, hospital wards, our homes, and shopping malls, where we need to have factories designed for robots rather than intelligent robots adapting to spaces designed for human beings, right? How do we do this arrow? And this is my focus of my research in robotics. I think this is the bigger impact of robotics in our everyday lives. So I view robots as the biggest tool, perhaps the best tool, where the robot doesn't work independently, but the robot is the best tool for the human. It needs a body, it needs a good brain, and the everyday task, anything outside the factory is the biggest really impact. I call this the 5Ds of robotics. These are tasks that are dangerous, dirty, degrading, demeaning, and more recently for driving vehicles, logistic applications, even public transportation. So to do that, we need improvements in the body, we need improvements in the intelligence, and these are some of the work in robotics that we're doing. And the high-level intelligence is how to do the sensing, planning, executing the plan, and learning as the robot interacts with the real world with human beings. And in the intelligence, this is some form of local intelligence, how it can do compliant motions such as this, how can you give the robot a lowest level intelligence of reflex action, and also how we can have mechanical intelligence such as this, a field called soft robotics, where the robot can be not intimidating, can be safe in our daily homes as such, right? Mobility is also very important. An example is how can we give the robot omnidirectional mobility. It can go X and Y motion and rotation independently. Imagine if our cars can also do this and parallel parking won't be a problem. And if our cars has an arm, a soft arm, and it will be my personal assistant. So I'm looking forward to our panel discussion and to discuss more about this, the problems and the future opportunities. Thank you.
Okay, thank you, Dr. Massaro. This is very interesting and a lot of heavyweight robots that we are seeing down here that definitely, well, I would say that may appear to be intimidating, but really bring out a good point that robot need humans and humans need robot to enhance our capability. Next up, I would like to bring in up Dr. Chen. Okay, Dr. Chen from Transformer, and he will introduce his company as well as his topic. Dr. Chen, please.
Transformer Robotics is a robot company that provides a built environment robot solution. And we are a spin-off company from NTU. The company will actually develop a few technology for the spray painting and quality inspection of the building. The major idea is that the spray painting job will be able to done by a scanner using camera, and also robot will be able to automatically execute a trajectory along with controlling the painting parameters. In terms of the quality inspection, the robot will be able to use AI to detect the crack and also the surface alignment, unevenness, and so forth. With modular hardware and cloud-based applications, we'll be able to create different kind of platform for different industry very quickly. So therefore, you can see that in terms of the surface coating and painting job, we can develop the various platform from the robot that go into the interior of the oil tank, as well going for industrial painting going to 10 to even 20 meters high. Here we show you the one of the examples. So this is the robot will paint the car park of a office building. So the robot will be able to scan the surface and then doing the painting job automatically. And the robot will be able also be automatically move along the wall to complete the job. Humans just need to do some pre-preparation work and final finishing touch. The quality inspection robot, we call it QuickBot. So what it does is we'll be able to scan the surface of finished building to check their alignment, evenness, and also some surface cracks. And the information you gathered will be able to be integrated with the cameras, so that the inspector will know the whether they're past the criteria or not, and the contractor will be able to go in to repair that. So our market of this, including the residential office and also the oil and gas industry for different type of coating materials. And also we doing the quality inspection for regular residential and also office buildings, and even in the prefabrication factories. And we also have a line of disinfection robot that will be able to go into the hospitals, hotels, or even transportation systems. Yeah, so these are all our key partners. We're working with many government agencies as well as international construction firms. Thank you very much.
Well, thank you, Prof. Chen. That is a very interesting presentation, and thanks for sharing that. Robot is not just help to improve the efficiency, but actually help us to do job in a very dangerous place, such as construction, oil and gas, and even disinfection. Thank you very much. Well, next up, I would like to introduce Gabriel from Merlaps, and he will introduce what he has been doing in terms of transforming some of the R&D eventually into very useful for manufacturing. Gabriel, please.
Okay, hi everyone. I'm Gabriel, the managing director of Merlaps. Merlaps is an A-Star spin-off, and me and my team, we were in A-Star working for a very long time, and we've always toyed with the idea of spin-off, but really never thought about it until quite recently. So after spin-off, now that we're out, I think we've been surviving for quite some time, and thinking about it and looking back, I think we probably should have done it earlier. Now, what Merlaps does is we create next generation robot sensors and capabilities. I know that's not very helpful, so maybe let me give you a few examples. Our main product right now is a server-free 3D positioning system that is faster than anything else in the market. We have also developed a secure communications technology that allows robots to talk and negotiate with each other, and also with environmental sensors and controllers such as lights, doors, elevators, and even mobile devices. We have an upcoming project for an all-in-one high-speed collision avoidance and trajectory planning hardware for robots. I think it's a great product because it will greatly increase robot safety indoors. And I think finally, we are also working on a very low-cost multi-camera array that is designed for real-time super resolution and depth perceptions. I think if you take a look at it, the capabilities where we are bringing, as far as I know, there's no equivalent products in the market. So, if you're a robot company, please come speak with me so that we can talk about pilots and test bed. If you're an investor, the tech is good, and I would like to think that we are worth your time to take a risk and perhaps mold us into an industry titan.
Well, thank you, Gabriel. That's a very interesting position that Merlaps is taking, because that all the robot need the parts and you are the one to provide the sensory for the robots. And I think that the more you are building, expanding, I think the more you are more relevant, because that all robots need the sensor, because that without the sensor, the robot basically don't know where to start and so on. Well, very good. And next, I would like to call upon Xing from Momentous. And he will share with you how to control the robots, I guess. Yeah, Xing, please.
Okay, thank you, Alex. My name is Xing. I'm a co-founder of Momentous. We provide a software platform that simplifies robot programming. We are compatible with a wide range of robotic arms and manufacturers. Our mission is to enable people to develop robotic solutions regardless of their technical or programming background. If you are passionate about robots and software development, we welcome you to join our energetic team, and you can look us up at our website, www.momentous.tech. And as you see in the video, right now, you can use a mobile device like an iPad to control the robot. You use the iPad to scan the environment, and then just by tapping, you can control the robot movement. And the background algorithm will calculate a lot of the complex things like trajectory, singularity, all for you within the tablet itself. And we also have an integrated AI model builder that allows you to build AI models that is compatible with robotic arms through the tablet itself. So everything from robot programming to AI, all done through the tablet. And this can really help to revolutionize and democratize robot programming.
Well, thanks, Yongxin, for a very interesting introduction of your company, because you make controlling robots sound very, very simple. Well, this is one of the major scale. Most of people that are controlling a robot, that seems to be so easy, but with GUI and all these things, it all seems so simple. Well, that segues us into our conversations or panel discussions that I would like to invite all the panel to basically help me to understand and help everybody to understand quite a few questions that a lot of people are trying to understand about robotics, because this is a topic that's not our daily life. So the very, very first topic that I would like to pose to everybody is that what drives the robotic rise, especially there's so much excitement in the technology about robots, right? Why is it all of a sudden that we are interested in it? Is it because of our human need, or is it because it's another craze about technology? Maybe I will invite Dr. Marcelo to maybe start the ball rolling.
Yeah, thank you. I think it's both. There are so many needs that are happening now that we can see in daily lives that humans ought not to do, or that we see technology can help. And at the same time, we see advancement in technology, specifically more recently on deep learning, that how robotics can have the intelligence of humans are starting to approach it. And so it's both the needs and also technology development. And sometimes the technology development will also create a need that we didn't think of, right? And it's an imagined need that once we have that need, that it will improve our quality of life. So that will be the third aspect. We don't know we need it only until we see, and you can imagine the benefits on some other needs. Then we can see, oh, why can I use a robot to do this also, right? So it's all three of them.
That's just very interesting perspective. But let me just swing over to Prof. Chen. Is that you are basically building robot because of, I would say, the industry and human needs. What is your take? Is it more technology driven or is it human driven?
From the construction or built environment industry perspective, this is really a industry-driven one, because in the construction site, there are fewer and fewer younger workers. Like in Singapore, the average workers on the construction sites are about 40, and then mostly in Singapore were foreign workers. And if you're in China, because China now is the biggest the construction industry in the world, their average worker now is 40 years old. And then they also look at 5 years later, that become 45 years old, which means that there are actually no more new workers coming to this trade. So therefore, robotics and automation for this construction industry become a really need for that. Yeah, this is driving factor for that. Thank you.
Yeah, especially Prof. Chen, especially in your space, you are also dealing with some of very dangerous place where the human is not suitable to be there. Yes. Especially, for example, you're doing disinfection.
Yes.
The place is probably not safe. Yes. Yeah, I think that's very good, and thank you very much. And let's swing over to Gabriel and Yong-Shin, because both of you are supporting the robotic industry, so to say. And what do you think? Is it technology driven or is it human need driven? Or for your case, is that the robot needed? Yeah, Gabriel, maybe you want to start.
Sure. So for me, I think when we look at robots, I think there's a quote by Arthur Young, which I really like. And that quote is basically, the purpose creates a machine. So philosophically, as humans, we have decided that there are certain tasks that we no longer want to do, or just wanted to do it much faster than another bunch of humans, right? So this is the purpose, and therefore, robots are machines. But I think economically, if we take a look at it, we see the emergence of new business models. We see robots as a service. We see more government grants and subsidies. We also see a lot more injection of investor money. Right? And it's funny for me because a lot of robot demand that I see does not actually stem from satisfying genuine human needs, but actually external factors that promote or push for robot adoption. Some of these are like things like your government incentives, or increasingly, which I think is quite worrying, is that the increasing use of hype, as a weapon to gain a competitive edge. Now, I don't think anyone would rationally be against this. Push-pull mechanics are an essential part of economic progress and competition. And not to be pointlessly contrarian, the real reason, in my opinion, is that we humans are actually evolving as a civilization. Not too long ago, the path to supernormal wealth is by being industrious. And we see this best exemplified by the robber barons like, Andrew Carnegie, Cornelius Vanderbilt, John Rockefeller, and even Henry Ford. But today, their equivalents are personalities like Pokimane, PewDiePie, and even Taylor Swift. I think the worst of it all is that, there's this increasing adoption of idealistic notions such as work-life balance, smelling the roses, and this whole treat yourself stuff. At a global level, this aggregates into less production output, which rationally, is best satisfied by leveraging on robots and automation technology rather than birthing out new humans, right? Well, that's my opinion, at least, and I hope that explains it. Because, the other scary explanation is that we are all barreling towards this massive behavioral sink, enabled by robots and AI adoption.
Thanks, Gabriel. I think you not just answer the question, but also bring up a very interesting point that, the craze and the hype could be just investment driven. People like VC, in my past life, that I've been doing investment for a long while. And for us, is that it's just boys and the toy. And we just look and love the shining technology and just put the money in. So I think that could also be one of the reasons, but of course, eventually for all business, without a proper, I would say that use case and consumer and customer, business will die, right? So I think ultimately, and you answered that questions, but of course that I won't dive into talking about GDP and are obsessed with some of the unnecessary number. In fact, that you look at China, they already start moving away from measuring their productivity GDP. So but that's a conversation for another day. I'll just swing over to Yong-Shin. And what do you think? Is it because of human needs or is it because of the technology? Of course, you're playing with technology and a very interesting technology that you have there. Yeah. Yong-Shin, what do you think?
Yeah. Okay. So a lot of our clients actually come from the SME side and the smaller companies. And for SMEs, normally they are pretty price sensitive. So a lot of them, when they actually make a decision to purchase robot, it's actually based on the decision on ROI. And now everybody of us understand that robots are becoming more affordable. And just like what Gabriel had mentioned, there are grants available from the government to subsidize robots. And now with a few $1,000, you can get a pretty good industrial robot. And therefore, we start to see that with the emergence of COVID, companies will start facing problem hiring people for manual labor. And also more local Singaporeans are actually tending towards office jobs. And that make a lot of SMEs have the trouble of actually finding local talent to fulfill their manpower needs. And therefore, start to see actually a lot of SME are really looking at robots to actually replace manpower, but not just every job available, but mainly for the dull, dirty, or dangerous jobs, which is the 3 Ds of robot tasks. So therefore, we start to see a lot of our smaller companies are adopting robots, and therefore the rise of robotics, at least in the Singapore local ecosystem.
But thanks, Shing. That is a very interesting point. I think you probably echo what Prof. Chen mentioned about the industry need. We are not having a younger workforce, and we are basically have to rely on the robot. Although human is probably one of the most versatile robots, if you really think about it. But the question will be that now we have a robot, we can't really look at them as just machines, but we have to look at them as a whole ecosystem, especially Merlaps as well as momentous is playing this space to support the robotic industry. But I would like to ask our panelists is that, what do you think that the development of new technologies, especially things such as 5G, AI, sensor technology from Merlaps, as control technology from augmenters, etc., how would it impact the development of the robot? What do you think? Where would the trajectory be going? I will pose this one to Prof. Chen first.
Yeah. Thanks, Alex. I think in terms of 5G, that will give our robot at the field with much better bandwidth to see and control. Because especially we know in construction environment, normally you will not have good connections. So with 5G, we'll have a much better control of the robots, because we know the robots, if I want my construction robot to be fully autonomous in the near future, I think is probably still very costly and still may not be realized. But with 5G and also human assistant, so that we can actually make the whole job to be done seamlessly. And AI technique also very crucial, because now all of our construction robots are pretty much using computer visions, learning algorithms, and so forth, because of the complex environments. So therefore, I think both of them are a critical push for robotic application, for a robot to push into more different variety of application and scenarios. Yeah. Actually, even beyond construction, if you look at the food industry, kitchen automation, all these are coming up just because of those 5G and AI.
Yeah. Thanks, Prof. Chen. I think you bring up a very important point. You said robot is not just used in a very limited field. For your case, is what's it called, constructions, oil and gas, and disinfection. But you can even push even further to be in the space of food manufacturing. And of course, with the 5G and AI, we even push even further that how about having autonomous mining terrestrial, sending a robot to do surveying of the ground on its own, and of course using the sensor from Gabriel, and how about mining up in the space among asteroids. So those are the very, very dangerous jobs that I guess robot should be able to do that, especially with the technology augmentation and improvement. That's what I will push even further. Dr. Massaro, what do you think that would the technology eventually enhance the robots, but eventually will reach some kind of autonomous, or you think that we will still be very much fixated at the human augmentation? What do you think?
Definitely yes. Let's start with 5G. The much higher bandwidth, speed, and amount of data that 5G can provide at a very fast rate will open up many new applications where the intelligence is divided. In other words, you don't need to put all the intelligence in the robot. It can be in the crowd or it can be in many robots. So that opens up more applications. You can build robots much cheaper now because you don't need a fast computer in the robot itself, in the side, in the edge computer, right? It can be now. There's so many edge computing, just $50. NVIDIA released the 2 GB uh, NVIDIA Jetson Nano for only $59 and but the higher level intelligence can be in the cloud. Now, technology in general, not only 5G, I think will democratize development, will speed up because tools are available right now. And we can see it in AI and deep learning. Right? You don't need to be trained in AI. There's so many tools you can use to do transfer, to apply models that can be used for segmentation, classification, and give it available to everybody, even if you don't have sophisticated hardware through the internet, right? So if we can have more sensors, more software, more tools, robots going down, more people can have the opportunity to build robotics applications. So certainly it's an exciting time. Tools are becoming more and more available to all, and all can contribute.
I think you bring up, Dr. Masaru, you bring up a very important word that you say that is democratize. Basically allow the proliferation of the robot, which I have another question which I will ask you later. Is that the robot become cheaper and you can even call it disposable, fire, use and forget about it. Of course, it will create some litter and eventually have to manage the rubbish that you created. But I think it's a very important point that what you mentioned is that with the technology advancement, we can make it cheaper and it can be everywhere and it will help us along the way. But Gabriel, what do you think? I mean, it will probably have a taxing impact on your robots. I mean, your products, the sensor, everyone will have to have one. Eventually, maybe have to integrate into the robot. What do you think that the advancement of technology will help with the development of robots?
I think there's definitely a few things. We are actually exploiting a lot of these advancement technologies, right? Some of these are smaller CPUs, MCUs, and NPUs. We are using that in our hardware. You're talking about computation powers that were not achievable 5 or even 10 years ago. We are already using that. We are using sensors that are still experimental. It's great how the economy works now. There's experimental sensors. You can use it with distributors. You can test bait it even before you actually roll it out. I think it's really great how the future looks like for robots. But I would say that these are very high level skills, and to find people that can do electronics engineering in Singapore, AI, or even optimizing algorithms from server level CPUs down to MCUs. Oh, that's a very different skill set, and I think truthfully, even me and my team, the three of us, I don't even think we've covered the whole range of it, even though I think we are pretty above average compared to other people. But I would like to talk a bit on 5G. The thing is that I think everybody thinks it's a boon. I think it's great. I think it's inevitable. The higher bandwidth, it's obviously something that everybody values. For us, we are talking about things like downloading new maps. And right now, what we are doing is we are actually experimenting on downloading AI models on the fly. That are optimized for the robot's current environment. And this is because, when we look at sensors and all that, we realize that one AI model for one environment to another environment, it's not actually completely translatable or transferable. So, the ability to download AI models on the fly, that's very helpful. But my issue with 5G is not the bandwidth, it's actually with the latency. I mean, if you look down really deep at it, a lot of the magic of 5G and how it reduces latency is by reducing frame durations. I think the innovation is good and is very significant. The problem here, unfortunately, is a choice of signals, right? Millimeter waves. I don't know. I mean, I'm not sure if it's such a good idea. I mean, issues with cancer, and myths that it spreads, COVID aside. I mean, we are dealing with the laws of physics here, right? And the scientific fact is that millimeter waves have very poor propagation characteristics compared to older generations of signals, right? This means shorter effective range and the dependency on beamforming. It gives rise to uncontrollable interruptions when robots need to switch from one base station to another base station. Now, I think the question is, would this make latency worse than 3G or 4G, or even worse, create a ton of dead zones? I don't know, but many experts actually think so. And when we look at this and we look at news and opinion pieces on the internet, I think we at Merlaps, we are hedging against this by developing capabilities that run on board robots, such that external resources and services are no longer and never ever needed.
Well, Gabriel, you bring up a very important point, actually, is the communication. So 5G is not just about radio wave and millimeter wave. That's actually the communication and what I term the command and control of the robots, because eventually all robots, other than a certain form of autonomous robot, but they all have to be communicated. So until we have so-called quantum communications that effectively ability to give us what's it called real-time terrestrial communications. We will probably still be relying on existing communication protocol for 4G, 5G, and the latency is definitely that kind of issues. So you're definitely right in the sense that I think the technology will have to move in that directions, and your sensor is probably more important, because that sensor will provide the kind of feedback loop that the robot can be safe, right? And thank you very much. And what do you think, Yoshi? Because you are the one who do the control of the robots, and how would technology development advancement affect, especially your business? Would that make your business out of job? What do you think?
Yeah. So for 5G wise, a lot of times when we interacted with some of the customers, a lot of them prefer to keep the robot programming aspect offline. That means a lot of them, even though there's an advance of Industry 4.0, and there's a push for it, actually a lot of companies, especially the smaller companies, prefer to keep everything offline and don't connect anything to the internet for the purpose of confidentiality. Yeah, so I believe 5G is a very powerful technology, just like all the other parameters I mentioned. Yes, low latency, large data throughput. And one very interesting application that I want to talk about is about using 5G for remote surgery using robotic arm. So in 2019, somewhere in China, whereby there was a first 5G remote surgery being performed, and the surgeon and the patient were around over 2,000 kilometers apart. And this was made possible because the 5G enabled the surgeon to actually perform very precise and delicate movement on the human brain, which was never seen before. Now, this actually is something very close to me, because a few years ago, my brother had an accident in Malaysia and his brain was damaged. And unfortunately, in that particular area, there wasn't any neurosurgeon around. And sadly, he passed away. But suddenly, it got me thinking that if he could, have access to 5G remote surgery, whereby a surgeon elsewhere can perform on him using 5G technology, then his life might have turned out very differently. So I definitely see a very huge potential for 5G to be applied in robotics for medical sector, whereby a lot of countless lives can be saved through this, regardless of the geographical location.
Well, you've been sad to hear about your brother incidents, and I think definitely 5G, what's it called, in the medical field with robotic augmentation, definitely is something that it will benefit a lot of people. But I think eventually we still talk about proliferations and how can all this robot be deployed first and on location before we can do that. But I'm going to focus on you a little bit more by checking that 5G, although it's communication, so you can kind of replicate. But to a certain extent, that I would say that Gabriel's sensor and provide maybe haptic feedback to the surgeon far away. And ultimately, the robot itself need to have some form of, I would say, the AI machine learning to be able to pick it up. So it is not entirely that the surgeon from far away that just operate, right? Because there's a lack of latency, just like we are in this Zoom session. So those are the already existing issues. So my question to you is that how does the AI and probably the natural language processing, NLP, will help to drive the advancement of robot, especially in the space in augmenters that you are playing with?
In augmenters, we use AI for image recognition, specifically for the pick and place application. However, talking about using AI in natural language processing, in short, NLP, It allows people to interact with robots through our voices alone. It's something very similar to the Marvel movies whereby Tony Stark could make robots move do his bidding just by using his voice commands. I had developed something similar, but not as sophisticated as the Iron Man one. A few years ago, I used Microsoft HoloLens, a kind of mixed reality glasses to control robotic arms. I'll look at the position through the glass and make the robotic arm move to that position just using my voice alone. For example, using voice commands such as move or rotate. And then you can see the robot, virtual robot movement overlaid onto the real robot through the glasses itself. It sounds really cool using AI to control robots simply by verbal instructions. But in reality, it's actually very tedious to keep repeating the voice commands over and over. And sometimes it's actually very hard for the users to remember the voice commands to make the robot move. So we realized that NLP, though powerful, still needs a lot of development in terms of user experience. And therefore, we pivoted and actually explored using AI for the robot to see instead of using AI for the robot to hear. Now, on the augmented platform, we built an AI labeling and AI model building feature inside that allows the user to create their own AI, drag and drop style within an iPad. Just like Prof. Marcelo had mentioned, right now, building an AI is actually a very low difficulty kind of task, whereby people just need to put your data set and then label the data, choose the right neural network, and then they can generate their new AI model. And this is what we are going for. But through all these AI features on the Momentous app, we simplify the process of building machine vision algorithms that allow the robots to see, respond, and pick up objects to develop their own pick-and-place application, therefore making it easier for people to program robots and lower the barrier entry for people in the robotics space.
Thank you, Xin. I think it's very interesting that when you focus on the technology on the vision, because that light travel faster than sound, of course, that you probably be able to pick it up. But of course, that also that vision can be misguided and misleading. So you may want to start exploring vision is actually beyond the visible spectrum and go into the other spectrum, or maybe even LiDAR and all something. I think that would probably be a very interesting technology development further than that. Well, I was just thinking of a sensor and all these things. I can't help but think of Gabriel, that is the area that you're playing with. Sensor is one of the very core things that the robot needs, because without the feedback loop, we can see the robot maybe crashing into a lot of things, and that is probably what is dangerous about it, right? So next generation robotic technology, so I believe sensor play a very important part. But then there's ultimately, like what I think Marcelo and Prof. Chen mentioned about it, is that things may get smaller, and a lot of processing power may now go to the edge. So what do you think about balancing the number of sophistication of the task and the limitation of processing power over at the robot side? Where do you think the technology eventually would evolve, Gabriel?
Okay, so with Prof. Marcelo and Prof. Chen's comments just now, I think there's absolutely no doubt that robots are actually getting more sophisticated. This is because we demand it. Not so much because we are inspired by what we see in the movies, but that we are actually paying more and more for robots, right? So it's a very tough world for industrial service robots, right? Once upon a time, they just need to go from one place to another place, collect something, and then drop it off somewhere else. But today, the same robots are expected to slam their way across like millions of square feet, to avoid collisions with humans and other robots, to identify items and objects, to be able to optimally grip and handle objects, etc. Right? And this is because people now they are paying top dollar, and that the robot that they are getting had better be as good or better than the robot that they just saw on some YouTube video. So, for robot companies, it's a very, very tough world, especially for those who are just system integrators. Because all these tasks, even with all these sensor inputs and all that, and all these high-level capabilities, they're very computationally intensive, right? And it's actually very tough to find trained staff who can successfully, don't say R&D, but rip and duplicate all these capabilities and then integrate it to a robot. It's a very sad fact that top-tier guys don't want to work in an SI, and SIs don't want to pay for top-tier guys. So it's a serious catch-22. And again, if you take a look at it, the stable equilibrium that we have right here, it's what I call Frankenstein robots, right? These are monsters that are coupled together based on whatever can be downloaded for free from ROS or GitHub. And looks aside, I think the most hideous part about such robots is actually the implementation of the code. And I'm talking about exceedingly bloated AI models, single-threaded Python code, unnecessary computation, and all these tasks are fighting together in this horrifying cage match, together with the rest of the Ubuntu bloat that you can squeeze onto a CPU that was chosen. Now, I mean, for a lot of companies, what they do for this is that they give the robot a faster CPU. And some of my partners are already running with server-grade CPUs. Some of them are in fact even running multiple Jetson Saviors. So these are very expensive equipment on board. So, when we talk about balance, the data that's coming in, the complication of tasks and sophistication of roles, I think the fact is that there is no balance. There's only the hope that if you chuck more compute power into the robot, the OS will magically deconflict all these tasks and your robot will be fine. But then again, that's no guarantee, right? Uber themselves has a confirmed kill. And we also hear about security robots in US that are committing suicide in water fountains. So really, I mean, are server-grade CPUs or NVIDIA Jetsons really the way to go? I don't think so. These devices are designed for lab use and not for prototyping, and definitely not for operating in the real world. And can I also say that there are actually limits to computation, and these limits are not even that far away on the horizon? I mean, we're at a 7 nanometer manufacturing process line now, and electrons are so physically close that quantum tunneling is now going to be an acknowledged risk. Now, I mean, breakthroughs in graphene production, photonics, and even quantum computing, I don't know. I mean, you'll be kidding yourself if you think that's going to happen in the next few years. And so, to me, I mean, we looked at all this because we're in A-Star and we had a lot of access and exposure to this. We thought and we felt that there must be a different way. And that's what we at Merlaps are working extremely diligently on. Right? We believe that the future of robotics is in the division of computation. What this means is that we separate tasks into specialized devices such that the whole may be greater than the sum of these parts. And from a technical perspective, this is actually a very sensible thing to do because not all tasks are equal. For example, sequential tasks are best done on CPUs, parallelizable tasks are best done on GPUs, and specific application tasks are best done on FPGAs. So when we create, specialized hardware that allows us to exploit such low-level idiosyncrasies and enable the possibilities of delivering performances that are not achievable by current solution, that's a very, very good thing to do. And I think a very good example of this is our Navistar positioning system, right? And yes, I know it's another positioning system, but I assure you that this one is different. We invented a completely new approach to using ultra-wideband signals and got it to function completely server-free. That means completely on the edge, right? We are calculating 3D positions at more than 150 times per second and can deliver this calculated data to robots in microseconds. Now, what this means is that your robots can increase their moving speed from 1 to 2 meters per second, which is like you crawling, to up to 10 meters per second. And that's basically a robot running faster than Usain Bolt. Now, without the mandate to design our own bots and to specifically choose the components to maximize the advantages of this approach, Navistar would not be possible at all. And I think this is why there's no academic team in the world that can actually hit the performances that we have right now. But to me, it's not about the performance data, it's about the spillover effects. And one significant spillover effect is the ability for us to drastically reduce the amount of computation for SLAM and the data that's used to reduce the search space. So one of our partners that we are trialing this technology with has managed to scale down his robot CPU from a high-end i7 CPU to a low-end i3 CPU without any performance loss. And we're not even stopping there. We're evaluating to see whether he can test another technology that might reduce his computation down to an Atom CPU or even a Cortex A75 for NPU. So we're talking about changing from a $900 CPU to a bunch of super cheap $20 NPUs. And so the cost savings are actually pretty ridiculous. And may I even say that this has actually made his robot a lot more robust. NPUs are way better at tolerating industrial environments and the poor power reliability of robots as compared to CPUs. So we're talking about higher fault tolerances and reliability. And I think these are very important considerations because robots not only make money when they are working and moving, and I don't think I've met yet to meet a business owner who does not get upset when his robot is like not moving or not working. Okay, now, I mean, I'd like to give you examples of our other works and our end goal of obsoleting SLAM, but I think I might be digressing. I think if I can summarize my long response about the balance of computation power and sophistication and sensors and all that, I think that it's inevitable that robots are getting more sophisticated. I think the academia and industry, they are zucking into dealing with this by scaling vertically. But we at Merlaps know that horizontal scaling is a winning strategy and we are already working on it. So, I mean, I'm happy to share more, but it's a very long conversation, and so please come and find me if you want to know more.
Well, thanks, Gabriel. I think you really bring us for a roller coaster ride that go from the high-end, super powerful, full of adrenaline rush kind of robots that are fighting in the cage, and of course, at all the consequences and all. And eventually, that what you're working on to be able to shrink down the robot into, I would say that processing at the edge and be efficient. I just want to bring us back and closer to what the reality is like, especially that Gabriel and Yongshin, you two are from the very young generations, and the rest of us, okay, are from the slightly more senior generation. So I'm going to pose a two questions to Prof. Chen and Marcelo. That what do you think about what is the robotic and automations augmenting the need of, especially the aging population, and what form would it take? Because that people like us who are getting a little bit more senior, we don't want to show that we are senior, and dyeing hair and dress funkily is the norm for older people. But what do you think about the augmentations for the aging population? Do you think the population will accept the exoskeleton is so big, or what are the form that they will take? Maybe Marcelo, you can try this.
Yes, yeah, definitely the aging population is a very, perhaps the top of the pyramid, the biggest use case as an assistive device, as a robot, as the ultimate tool. Not only as an exoskeleton, which is physical assistance, there's also social assistance, there's also companionship. This will be, if you're living alone, you can still be connected to the world through this robot. Maybe the robot will be your Zoom device, like what we're doing, and can do haptic interaction too with your loved ones through Zoom and things like that. So it will be also your Wikipedia, yeah, for finding out knowledge. It's like your the best companion, like Siri for the Apple, for getting knowledge, but at the same time for physical assistance too. So definitely, it's not necessarily have to be an Iron Man type exoskeleton. It can be something that you live with for physical and social augmentation, and really not for the robot working alone, right? But really collaborating with you, helping you, your ultimate personal assistant, ultimate domestic worker, ultimate lifelong companion, or your spouse, your loved one. That doesn't really replace humans, but really is your connecting to the world. So exciting.
Well, thanks, Marcelo. I think you paint a very interesting picture. I don't mind having a Iron Man suit myself. Of course, I'm probably not as handsome as the actor down there, but I think you also bring us to a little bit more creepy space that having a robot as a lifelong companion, they probably can outlast you because they can be replaced and refurbished. How about you, Prof. Chen? What do you think about the robot in the aging population space? Yeah.
Okay, I echo Marcelo's opinion. I think there is social aspect of it. For example, just like social robot interaction. Yes, I think this could gradually grow. But the issue mostly is for elderlies. Of course, companionship is one. But apparently, if you compare to other, really helping the elderly worker that go back to the society wise, that demand for the social robot now is still not a really the hard demand because we see many social robot company on and off, on and off. So I think this wave still continue. They haven't really reaching that stage yet. But there are augmentation, of course. Exoskeleton is one, but if you consider the other perspective, it's just like a semi-automatic assistive devices. We actually help the supermarket to develop those system to help the senior workers to make their job easier. So some of these things, I believe you will see more and more, just like because wearable device has its own limitations. Yeah. But the other assistive device just helping out, bring so he can make his work easier. I think this is important thing because like in Singapore's the mandate is we want to keep the senior workers. We don't really want to lose them, but the only way we could do is to develop certain tool to help them. But this, in fact, I think is also help. Actually, based on our field test results, it looks like actually the younger worker also interested in that, because in fact, workers at different age group, then using those devices, they will have different kind of productivity effects. So therefore, how do we make sure the robots or AIs, right, suitable for the aging workforce? I think this is also very critical. And actually, my thinking is that if we can make those tedious work to be, or take care of elderly patients, or in the factory works to be more automatic, then we can release those manpower to really go back home to help the elderly. You see, this is the because a lot of people are really busy with the work, they have to sacrifice the families, right? So if there's a way that we could also help them to do the work, for example, just remote control the factory works, and that he still can work at home, right? Just like what we're doing now, but instead of just as COVID-19 measure, that become a norm for the operating the whole system. This I believe, we have so many young entrepreneurs. They're also looking at all those spaces. So I believe this way will also help us to solve some of the issue, because some complex job, we still say human is much better than the machines. So the only way is that we have to get the other job, make it easier, and then we can go back to our human nature. That's
Project, Project, I think it's a very, very important comments, and not just philosophical, but it's about robots eventually augment the human. It may not be just about age. So different needs that basically look at based on need instead of based on age. And of course, the movie has romanticized all these kind of robotic things, and of course, I think that is one of the core issues because we're affected by the media, and the population of the social media eventually can kind of swing our opinion. And I think it's a very important point that you highlight, which I segue into my next question, is that now we're talking about robot and human, and we coexist. It is not that robot will do something and then we will not do something, right? So robot is there to help us, and robot is also at the same time free us to allow us to do some of the things that we want to do. So the key question that I have next is about the coexistence of robot and human, especially that all of you are say the technology developer. You will develop a particular technology to serve all these things. But where should the line be drawn that what should the robot do and what should the robot not do? I mean, you talk about the surgeries that you want the surgeon to be behind controlling the robot, or should we let the robot just take care of everything ourselves? I mean, we talk about mining that's so dangerous that, I think we probably don't mine that. Throw the robot out there and we can mine some gold and bring it back. That's good. If we can't, then forget about it. So there's a kind of robotic as a service kind of concept. But what should the robot do and what should the robot not do? And delving further down is that how do we strike the balance between the human and robots? Because I increasingly see that from our whole conversation, the line is getting very, very gray. And what are the pros and cons of implementing robotic versus human? Of course, at a lot of time, being a financial background, although my technology is in AI, but being an investor for so long, I will practically be looking at ROI, capital investment. So this may not be humane to do that. So I'll pose that to Marcelo and Prof. Chen, that what do you think? The coexisting of robot and human, where should we draw the line?
Yeah, there are two aspects to it. The first is the Ds that we talk about, right? I call it 5 Ds. Dangerous, degrading, that humans ought not to do. But the problem is today's robotics technology may not be able to do all the Ds yet, right? So it's still evolving. That's why you say the line is blurred, because where divide depends on technology advancement. So that's the first aspect, the Ds. And the second aspect is tasks that machines can do better than humans, right? And where humans can do better, you let the human do that part of the task that humans are good at, and machines do not know how to do that, right? Very good example is self-driving vehicles, for example. Humans are machines potentially are better than humans because machines do not get tired, do not get emotional. You overtake me, it's okay. Yeah, do not do revenge and things like that. And also, but the problem is the planning, right? How to overtake exactly, right? Humans can still do better than how machines, right? So this is how you decide, right? What are the things that machines can do better, like object recognition, right? Right now, right? Uh, Deep learning has shown that machines can do better in classifying objects, recognizing objects than humans, right? But there's something about what we call point cloud completion, for example. Humans still doing better than that. For example, the machine sees only a partial view of a chair, but the humans can imagine how the whole view of the chair looks like, right? So this is, but this slide changes over time as technology improves. Humans do less or do new things. It's about transforming lives, right? As technology improves, the line gets higher. We raise the bar, and humans can do less boring, mundane tasks and leading to more meaningful lives, right? Like what Ining said, perhaps we don't need to come to work. We can be in the comfort of our home, doing some remote control, not really control, supervision. The machine has low level autonomy, getting better and better. Humans still always in contact, but doesn't require high bandwidth, only supervisory control or for exception handling, right? So thank you.
I agree with Marcelo. Actually, this line is keep changing because the technology is still progressing. So there's this as one aspect. But if you ask me from some specific examples, uh, there are situations that you really need, for example, human intelligence. For example, like our spray painting robot. I can use human to move the robot into the construction sites. Because that you sometimes you don't need autonomous navigation. It's a human movement become very intuitive. However, when the robot start to scan the environment to do the painting job, because a large area have many geometries, so you just park the robot there and then press the button. You will just automatically scan and then do the rest of the work. So this, in fact, is kind of autonomy. You have autonomous feature, but you also have a human operating feature of that. And so this is you know, and if you really want to make a full autonomy, that become a very complex job. You're talking about robots with so many degrees of freedom. Yeah. So in this situation, we really need to look at the task itself. Some of them, yes, the robot can do very easily. For example, even the robot going through a very narrow corridor, right? This is with the sensor running, then it will be quite easy. But human, I using my hand control, may not doing the good work. So something this become a very important. And then secondly, in terms of some of this play in terms of ROIs, yeah, this everyone keep talking about that. Yeah, but only until the robot can be super cheap, people can always say you can have the ROI perspective. However, there's one thing now is important is um, actually using robot is not just ROI issue. There have many other perspective, quality of the job and so forth. So therefore, when we doing the deployment of the robot, like disinfection robot or some of this, we're always encounter this. Are you talking about headcount-based contract or outcome-based contracts? So if I do outcome-based contracts, then I can deploy a robot. If you talk about headcount-based things, then there's no way we can achieve it. So therefore, how do we address those issues? Actually, also depending on many other structure, commercial contracts and so forth. It's very complicated, yeah, because when we talk a robot, talking about just purely technology, I don't think we have winning chance. Yeah, but if you need to looking at the overall perspective, how these things will impact the economic impact, social impact, and so forth.
Thanks, Bob Chen. I think you have really given us a very provocative so-called argument to look at it, because the line really can't be drawn. Rather, the technology will still continue pushing, and the humanity will look at the other aspect of it. I think that's a very good and probably warrant a much longer conversation. But unfortunately, our time's run out. And with that, I think thank you all the panelists. But before we go, we have gone from looking at the technology and the application, the human needs and all this, eventually to talk about the philosophy of robotic work together with a human. I think that's a wonderful conversation. With that, before I close, I would like to ask everybody one last question. What do you think, okay, our robotic future will be? Maybe just about 30 seconds, each one, that people voice your forward-looking. And I hope that it's not going to be a robot apocalypse kind of a scenario, like what I think Gabriel was alluded to. Yeah, but so maybe your closing remark for that. I will start with probably the youngest, Yuxing. Yeah.
How we imagine the future will be whereby people can program robots on their own, and people feel comfortable with robots, because nowadays people are afraid of robots. Afraid of robots, being dangerous or replacing jobs. But what we foresee is that as robots become more and more common, people will become comfortable enough that because programming them seems like a PowerPoint, as easy as PowerPoint.
Thanks, Yoshing. Gabriel, what about your closing remark? Yes.
Well, I mean, like I said earlier, I think at Merlaps we really believe, in the division of computation. We believe in specialized devices. I think this is very helpful for businesses. This means that you don't need a big R&D team. You just stick a couple of our stuff together, like video computer, put your mouse and your keyboard and everything, and then you have a pretty good robot. I think, just to be correcting, I don't think we believe in a robot apocalypse taking over humanity. I think that's a very long time away. I mean, it's 2020. They've been telling us that since the Industrial Revolution, and I don't think any of us feels that we are living in the future. So, robot apocalypse, I don't think it's a credible threat. I think there are other dangers rather than the robot apocalypse.
Well, thanks, Gabriel. Thanks for a very good assurance. How about Prof. Chen, your closing remark?
I think robot will coexist with human will be a long time. And then, honestly speaking, we have now more robot developer than the real robot use. When we get the people to really interact with the robot, then they'll be able to, alleviate the concept of robot were taking over human. So, education, promotion, this is very critical. That's my conclusion remark.
Yeah, absolutely. Okay, education, especially that dealing with all the fake news. Yeah, I think that's a very, very key point. Dr. Marcelo, what do you think? You are on mute.
Yes.
Dr.
Yes.
Marcelo,
Yeah. It's very exciting. It won't replace human, but it will transform our lives. It will make our lives more meaningful. It will extend the longevity of people. Our senior citizens can live happier lives, productive lives, all towards the end, right? It's like raising the bar and how best to do that. So I don't see really robotics replacing humans, or maybe to qualify, it's really replacing the jobs that humans ought not to do anyway, right? Yeah, and really makes life really exciting, right? And we will see perhaps one day, like how we see phones that we carry every day in our hands, the phones, right? Perhaps one day everybody will carry their own robot with them, right, as their assistive device, right? Thank you.
Yeah, thank you, my panelists. Come to an end for this particular session, talking about leveraging robotic and automation for now, next, and beyond. Thanks, my fellow panelists, Yuxing, Prof. Chen, and Dr. Marcelo, and Gabriel. Thank you very much. And I wish everybody have a wonderful day today. Thank you. Bye-bye.
Thank
Thank
you.
you. Bye-bye. Thank you.
Thank you.